Good morning, this is Cody Henriksen, and today we're going to be talking about how you can build a Java database controller. This works within my Java program as well as my database development program, so if you're looking at that, that's what we're starting off with and what we're going to be going for. Before we get started, I want to address a couple of the vocabulary concepts we have to make sure we address as we work through this. The vocabulary we have to address as we're going through this, we have a couple things we actually want to make sure we understand as we're working with the database system, and so make sure you have a good idea of what these things are. We'll be using these vocab for this video as well as a lot of our subsequent videos as we go into more of the Java database connection structure. We have the connection itself, which is the object we use to actually hold a relationship between the Java program and the database we're talking to. The connection string, we'll talk about quite a bit of detail in just a minute, but it's how I make that connection, the information I need to send to it. The driver is the tool that actually makes that connection happen. The metadata, or as you've seen in your English classes, the data behind the data, which tells us information about what we're actually working with. A prepared statement, which is a tool in Java that allows us to run queries and inside our actual Java system. The query itself, we've been using those in database line quite a bit. This is just, again, the same thing, how we can actually send information to a database. Result set is what we get back from that. It's a dynamic structure we'll talk about quite a bit. SQL injection, squirrel injection, squirrel injection. That's how we can actually do a negative attack or something to harm data, and something we have to actually make sure we're working to prevent as we're working through this. And finally, SQL exception. This is what's going to be happening as a handleable component at almost every single query we run or command that we run inside database land, because almost everything could cause an exception as we run through that. And so you have to make sure you can address that as we go through. But that's some of the vocab we want to make sure you understand as we work through all these videos and go through the concepts of connecting to a database. The first thing we have to do when we're talking about building a Java database project is there's some questions we have to answer. These are the questions we'll be using so we can actually make sure we can make a connection to a database. And this is what we have to ask. What kind of database are we looking with? There's a variety of different database systems that are out there. We're working with MariaDB in class right now, but if you can do the same kind of approach by supplying the correct information to work with the Oracle database, to work with a MySQL database, to work with a Postgres database, or even an Access database. But that's okay. Where is that database located? You need to know the address of the database. So where is it found on the internet? What network is it talking to? So that's one thing we need to make sure we know. This could be a very simple, just a IP address. This can be a big, huge network path. All sorts of information you can send on that. The next question we need to make sure I can answer is, what is the database's name? We're not talking to the server itself. We're talking to a specific database. Because when we're working within this, we're talking about one specific set of data. So you need to find out what database we're making that connection to. Who are you? When we're working with the database, we need to make sure we identify who the actual user is. This is information that needs to be supplied to a program so we can actually talk to and use the database. And then finally, we have to make sure we get the correct password. Now, as we talk about password, I'm going to stress this as we go through this video and others as well. We have to maintain security and privacy. Previously, introductory computer science and database courses have skipped or skimped on the concepts of data security and data privacy. What we're seeing now that concept of security and privacy has to be addressed from even the beginning level computer science students, because the problems of violations of security and violations of privacy have real, huge, and large impacts across the real world. So you have to make sure we address that early on and address that early. So the first thing we're looking at is the connection string. These are those questions we just talked about a minute ago when we're talking about how we actually make that connection to the database. Those answers need to be saved and stored so we can build a connection to the database. In Java, we do that with a URL. Now, this URL is not the URL object, but rather a string that has a URL format to it. That's how we actually access the database. The answers from the previous questions are actually how we build that. As you can see right here, we have JDBC and then driver type, whether it's MariaDB, Postgres, Access, etc. We get the driver type we're working with, followed by a : // just like in the HTTP system. And then we have the path to the database. So this can be as complex as necessary, making sure you're using any directories that are, make sure you supply the entire full path to the connection string. Don't just give the server if there's a path that goes along with it as well. Finally, we have the name of the database. Then we have a question mark user equals username and an ampersand password equals password. These are the standard URL interrupts that we'll see when we're talking about anything we're working with. When we see, for example, doing a Google search, you'll see those things when you're using any dynamic website as well. We have the URL interrupts of question user equals and ampersand password equals. The question mark means it's always the first interrupt in the URL, which means we're going to say we're going to stop talking to that server and we're going to send it information. The first bit of information we're going to say is the user is and then username. The second bit of information is password is, and then whatever the password value that is supplied. There are other interrupts we could send to that to sending our connection string, but these are the two that are required and the one we're always going to be working with. So that's where we're having those right there. If you have others you want to connect to, like say for reconnection options or blah, 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 you can add those after the password, but those are the ones you are always going to be using to start off with this. We also want to make sure that when we're building this, that we do some string content validation. Before we actually execute any of the queries, we want to make sure that we actually validate the queries are correct and valid to be used by what the program is for. So because we're talking about a very simple program, we don't have to do anything extra special in this, but we want to make sure that if someone else gets access to this application, they won't be able to use our program nefariously or for negative purpose against the database. So we're going to, so to prevent that, we're going to create an array of strings that are unacceptable, things that cannot be inside a query to make sure we're preventing any malicious intent. So for data security, we have a couple that we're working with. Specifically, we're not going to allow drops, truncates, or the string or 1 equals 1. Obviously, with drop, we're not going to let them destroy the actual structure of the database. Are they going to be able to remove all the rows at once using truncate? And finally, with or 1 equals 1, can they use a squirrel injection or SQL injection to actually run nefarious other queries on top of that? Because it's one of the most standard ways to do a SQL injection attack. We also maintain that we have structural integrity of the actual database. We don't want to give other users permission or destroy information or access from other users because we don't want to cause problems with that. So we're going to also block the commands of grant and revoke because, again, that should be happening by the database administrator, not by something that would be happening on a very small application level instance of a database program. So by having an array of strings like that we can iterate over and prevent any of the queries we're running on our project have those commands inside it, we'll prevent some basic attacks and also maintain some structural integrity of our database available. So that's what we're going to work with to start as a basic format. We have some query types we're going to be using. There's a couple different query types we have when we're working with a database. We have either modification-based or table-based. The modifications are for insert, update, and delete commands, and we're actually just going to be changing the contents of a table. When you're using the modification-based ones, we use the execute update because it gives us nothing back except for the number of rows that are affected. So it's just a quick little int. We'll talk more about that as we go through. We also have the more common and more powerful select-based ones. We use at table. And that uses the execute query method. And that returns a result set, which is the dynamic tool we talked about earlier, and we'll go into a lot more detail, that is the storage of all the results, aka the giant table of information that happens when you actually run a query that you see normally when doing a database query inside your server. And so those are different types of information to do that. So again, we have execute update and execute query to differentiate those two. Now, if we're going to do a simple one, just the basic update change or something like that, we have a simple DMA statement that return an integer based on the number of rows that are affected. First thing, of course, we always want to validate the query. Make sure we're not sending improper information to the database server. After we validate the query, we create a prepared statement object using the connection and that query. Now, we can make that prepared statement even more powerful by using parameters to that, using a couple wildcard symbols. By using wildcards and parameters, we can have an even more powerful sequence. We can put that through a loop using data structures and go through and loop over the data structure, repeatedly calling the correct query for all the items inside that data structure and doing some really powerful updates to a database. For each of those statements that we're working with, we call execute update, which returns the number of rows that are affected. And we want to make sure that that count matches. This is something that if we know in advance, we can check that and have a more secure, valid execution of our problem. After we've executed all the modifications, we want to make sure we close that prepared statement because we want to prevent any man-in-the-middle type attacks. And again, anytime we're done, we always close things when we stop using them. That's a very important process when we're talking about a connection-based thing like a database. It's expensive on the resources to maintain that, and we also want to maintain the security and privacy of the data attached to it as well. On the other hand, we're doing the more powerful queries, aka a select statement. We're retrieving data. And so again, we start off with a query validation, just like always. We're always making sure we're keeping security and safety of our data as one of the first things in mind. Again, we create a prepared statement based on that query itself. Same basic approach. However, instead of calling execute update, we call execute query. Now with execute query, it's going to return a result set object. That result set object, however, is a dynamic structure that is continuously going until it's done. So this is a little bit different what we've seen in some other Java programs. We'll see this in action in a while when we do some of our bigger queries, but you want to make sure, like I have there in big and bold and red, this is not finished. This is something that's not done yet. You have to make sure you handle that result set properly. After you've created the result set, you want to make sure you tell that prepared statement to close upon completion. You don't want to close it immediately because if you close it immediately, it's going to shut down and you're not getting any data out of it. That was pretty useless. So instead, we tell it to close when it's done, and we can handle that by using the proper tools that we have available for it. As we have those results are available, as long as it's still open, we continue to work those results and go from there. And the first thing we want to make sure we do when we're getting our results is we want to make sure we get our metadata. Now, you've talked to the English teachers about getting the data about the thing, talking about what's the data behind the system. You also work with this in your science classes as well. But the metadata in a database query is the information behind that. It tells us about the number of it tells us the number of columns that are inside the query result we have, as well as what types of data are inside that. And that gigantic bit of information right there can really help us how we can display it, how we can parse it, and how we can use that to send to other objects or create things from that. One of the things we do have to remember, though, is when we're talking about the columns and the data types attached with us, so rows as well, that the indices in here are based on one not 0. 0 is a Java-based thing. However, in database land, it's always been on 1, 2, 3, 4, 5. They count like people do. So you want to make sure you keep that in mind whenever working with the columns and row counts, that's based off of the human counting system of 1, 2, 3, 4, 5, not the computer C++, Java, C#, Swift style counting system of 0, 1, 2, 3. So you want to make sure that index item is understood and remembered because you're always starting with 1 on this when we're talking about. So when you send information to that, if you're using a standard for loop or something like that where you go start at 0 and go to like my slides or whatever, make sure you remember to update that by 1 because otherwise you're going to cause out of bounds exceptions. The metadata, because it's part of the result set itself, you also have to remember it's only available when that result set itself is open. So keep that in mind that you get the metadata first, you use it, and then store the information you need to keep in another structure because once that once that result set is closed, that metadata is no longer available to you as a user, or as a programmer. So make sure you have that taken care of. Once we've got that result set, then we need to actually retrieve that information. As we said, it's stored in what's called a result set. It's a dynamic structure. Now, as a dynamic structure, it can grow as to fit whatever it's going to be doing. However, when we retrieve the result set, we only get some at once. All the stuff that's in the query from here and below, it's still there, but we can't access it yet. What we have to do is we have to consume it. So the column count is fixed for the entire structure. However, the row count is processed on a need-to-know basis. We use a next call in a loop so we can consume those results. And every time we hit next, we go to the next one, next one, next one. And that was used in a while loop so we can go through and eat all of the stuff until it's done. Once you've processed all those results, close your result set. You want to make sure that you always close when you're done with something because we don't want to leave anything open for man-in-the-middle type attacks or have a resource drain because we're using network connection. So again, we make that connection, we read the stuff in as we need it, and we store the information in another structure so we can close the connection as necessary. That's something we'll have to make sure we process as we go through. And again, we'll see the example of this in the other video when we talk about the actual structure of how to do that with code. But the process, again, go through, use the next call to go through and read all the data, and then close it and process it and move on. So we can handle as much as we can and get the data first and then process it again later. Just as a quick review, the concepts we talked about today so we can make sure we understand what we're working with. You want to make sure you can ask questions about the database and who needs to use it so you can build your connection string. Before you run anything, you want to validate any of the queries you have. There's 2 different types of queries we can have, either update or table-based. We modify tables with an execute update call, and we retrieve data or call a select with an execute query call. As we retrieve data, we get the metadata, the result sets, and then we want to make sure we always process the data first and then close it so we can move on. So that's the basic structure of what we're doing. Thanks again. We'll cover more details and exact Java examples of this in other videos, and have a good day.